Audio check. 1, 2, 3. Okay, try that one more time. I think it's my local settings, not an issue with the stream audio. All right, sounds good. How's it going today? Today, JTL, doing great. Doing great. Oh, yeah. Doing good. Slowly getting ramped back up for the week here. Let's see. This is the wrong project. So let's pull all that. That was a pretty productive Friday. I think I got stuck longer than I needed to in a couple of spots, but we got what we needed done, which was the goal. So, we need to bring up our current project and scale it for the stream. There we go. So, last week, we did a bunch of work on our archer. Our archer walks left and right on the chalkboard and draws the bow and aims the bow. So when we right click one more time, oh man, I thought I'd get alcoholics today, but it looks like I might not have any alcoholics. Shoot. So Robin Hood's getting close. I don't know if I care about that one. This one we need to deal with. Probably this one, a target, a score. We do want this to happen. We can't right click an arrow to bring it back. Dun, 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 dun. So basically, $24. We need to gather our end of week stats for the week as well. And today, today is December. That means it's time to remind people, if you have Amazon Prime and a Twitch account, you can subscribe to me. So in theory, that doesn't cost you anything, and it gives me a couple of bucks towards my mate fund. I mean, ideally, I want to make all my money by selling games, not by streaming, but you know, every little bit helps. So here's that. Okay, so we need to release FPS and release size. So one thing we need to do, bring up our to-do list. We have a couple of loose ends we'll probably tackle early today, just to knock them off the list. Just try and get warmed up and started up this morning. So we need that. So I need to shell up. So this is branding stuff. I do have a new song I'm integrating, so that's fine. Just add everything. None of this is significant. Like I was working on the Steam store. They want an icon and whoa. JTL subscribed to the Prime. Thanks. Appreciate it. I'm actually a little embarrassed how long it took me to figure out how to connect my wife's Amazon Prime account to Twitch. I had to Google that myself, but Awesome. And the best part is it's taking money out of Amazon's pocket and putting it into mine and not taking it out of your pocket. So win-win. It worked. Should have done that a long time ago. Was not aware. I'm still playing on Twitch. Well, so am I, and I don't want to be like every single stream. Hey, you know, Twitch Prime subs and you know, telling people they need to sub, because I don't want to make money off of Twitch, but or not much money. But I figure if I hit it once a month, first stream of the month, that's not too obtrusive, right? Okay. So, no alcoholes with my mate today. Back to gum. This is like branding work for Steam and website, which I've not bought yet. Song update. Yeah, we now have 2 songs. So that's going to take up some time. Once a month is pretty reasonable, I thought. So back to gum. Yeah. Only sort of. I'll still eat other things, other treats, but try to limit myself a bit. Okay, so we've done that. Let's go to somewhere, doesn't really matter. We're just going to do a clean and release build. And that will take a few minutes. But we'll measure our FPS and the size of our executable, which probably got considerably larger since last week, since we've added another song. It might not be that big. Yep, got the Christmas tree put up this weekend, got the Christmas lights on it, put all kinds of lights and garlands around the house. I've still got to run lights around the outside of the house. Might do that this evening. And I have to start making Christmas candies. Every year I make two large pans of caramels and a pan of panucci. The skeleton needs lights. Yeah, I think I need a Santa hat on him. G. Finelli. How am I doing? I'm doing good. I'm doing good. We're just running a release build from last week so that we can take some measurements. While that's loading up, metrics in from the weekly. So we'll need a commit for that from last week. Should be what, the 28th? Need a hash. I don't have times. So I'll get some of those. 23. How are things going with you, Finelli? Let's see here. Last week, Wednesday. I'm going to go ahead and just take today's latest commit. That's probably good enough. Times. Struggling with writing the query for the ECS. Found a bug in the index allocator. Nice, nice. Finding bugs is always good. It means you're one step closer to removing a bug. Can't remove it until you find it. We only streamed 3 times last week, so 526.46. 552, 57, 539, 24. Because Thursday was Thanksgiving. We did not work on that day. We were too busy eating turkey. Good stuff. How's that compilation going? Yes, ECS, Entity Component System, for those who are listening in, is your game defines an entity to which you can attach different components, and each component implements certain behaviors which are called automatically by the scene or by the game engine. So, however the game engine lays things out. Typical things are like on create. So when you create an object, its components all get called with their create methods. On update, on collision maybe, or, well, that would be certain components would. Other components would have a on render, all sorts of things. And the game engine goes through each entity and says, hey, fire off your components that matter at this stage of the processing pipeline. So if he's writing a query for the ECS, found a bug in the index allocator. That could mess up your ECS because you're using your ECS to manage a lot of resources. And if it's not indicating indexing or allocating correctly, it's gonna blow up. There are some fun things like if there's a quad, create a mesh for this entity, the renderer gets a mesh. Yep. Yeah, because you have meshes and shaders and textures and lots of pieces. It's very complex. It's a complex system. The sound warehouse is going to take a little while. The reason these two take so long, the image warehouse and the sound warehouse, is that I take every image that needs to be in the game and I load it up as a PNG and I get the raw pixel data out. And then I write that into this file. So every pixel is 4 bytes. So my image warehouse is 60, 70 megabytes worth of image data that we've embedded so far. The sound warehouse does kind of the same thing for our audio. And that's embedding, that takes a WAV file and embeds 2 channels of 16-bit PCM sampled at 44.1 kilohertz, which ends up being a lot of data. Actually, most of our data is sound right now with those 2 songs, because the song plays continuously, so they're kind of long, 5-6 minutes of that much data. But we have some tricks we're going to employ to shrink those coming up in the next couple of weeks. Let's take some measurements. Source builds release. Word sleuth. And all we really care about got the sound pretty quiet. Okay. We're just checking to see if our, oh, we've got VSync on, don't we? We can't measure our maximum frames per second unless we turn that off. So what vsync does is it basically says we're going to sit here and wait until the computer tells us it's drawn a frame. So if my frame has a maximum refresh rate of 30 frames per second, my game gets control every time it renders a frame. It renders a frame that says, oh, now you get control back, game. And then I quickly hammer out everything I need to draw the next frame, and then I wait. Okay, if we turn that off, we're sending more data than our screen can actually render. And right now we're still under 1 millisecond draw time. So we're up around 1500 frames per second, 14 sometimes. Yeah. So your CPU is gonna, be loaded by different background processes. Ultra Demon Lace Rhino Proud Vines. Little dude walks back and forth. Not bad. Right click draw. He'll shoot eventually. A little bit of popping, but that's fine. So I don't know, I guess it's looking more like 1400 frames per second. We are loading up more and more things for it to do, so it's not surprising. What do we say? Probably 1400. It dipped to 13, went up to 15. Source build for these. We're back up near that 200 megabyte mark for audio data. We added another 50 megabytes, which we can see here in our shell. Oh. A lot less stuff gets logged out when we're in clean build. Okay. Oh, we can still look at it in the log file. We do have a log file. We don't care though. Okay. So we're just going to commit those bits of documentation. We'll pick out our work for the day. Bugging the index allocator is easy, just thinking about it. Yep. Bugs are interesting creatures. Sometimes it's easy to find them. Sometimes it's hard to fix them. Sometimes it's the other way around. It's hard to find, but once you find it, it's like, oh, that's easy to fix. It's like a whole square of interesting variations on bugs. Okay, so I want to choose up some tasks. Just a couple of easy ones, just as warm-up. Okay. Ctrl-Q. Is that part of application? And all we want to say is here. Where says it? See, your global does. We just want to wrap this here. If Steam is enabled, if Steam is not enabled, let me quit anytime. So that's that one. And I think the other one is in scene. Anything FPS related. Blah, blah, blah. This is if not defined deployment. So I want it in my release build. I want it in my debug build, but not my Steam build. FPS. Withdraw call counts. That was part of it. Okay. Update FPS goes away. And then this thing. I think that's basically it. To be honest. Hey, LC Kangaroo. How's it going? To be honest, pardon me. To be honest, it's both easy in this case. I'm just with a clouded mind today. Yeah. Mondays are hard to get traction in sometimes. They really can be. Gotta get the blood flowing, do some jumping jacks. Pick a couple of easy tasks just to get moving, get some traction, get some momentum. So I'm gonna clean and debug build now. It's take a few minutes. It's all right. Trying to wake up, to be honest. Yeah. Oh yeah. Me too, sort of. Bonk. I'm just trying to knock down a couple of easy tasks, warm-up tasks. Okay. See, working on the game today. Animations. Yep. We're trying to wrap up this archer. He's by far the most complicated thing we decided to do, and I spent a lot of time doing art, which I'm not artistic, so everything takes me way longer than it would a real artist. But I think it's looking okay. Just takes me a long time. Hey, Javest, good afternoon. How was my Thanksgiving? It was delicious. I ate so much turkey, mashed potatoes, rolls. My wife probably makes the best rolls. Yams. Oh, it was so good. I thought he looked pretty good last time. Oh, thanks. Thanks for the encouragement. Always good. Yeah. I've only really maybe got a couple of small animation pieces left. I think all the complicated ones are done. Maybe we'll have him die. That could be fun. I would laugh if I was playing a game and I discovered that. Our artwork is significantly improved. We have a bit of music for a couple of different game modes. Really come together. Finally, I think I've got the store, the Steam store front moving the right direction. I've tried a couple different art things. It always takes me longer. I think we've got a good start on it. And how was your weekend, Dravest? He has a dab when you click on him. Maybe he could do dab when he dies. Oh, dab and then just fall over into a pool of blood. That's not a bad idea. We'll see what happens if we get there. Because right now he has a maximum angle of 70 degrees. So if you max out your power to where it doesn't hit the top edge of the chalkboard, he will have to march forward into the path of the arrow. And I don't know if we gave him enough speed or what. We don't have the arrow flying yet, so. But I do like that idea. He just drop his bow, dab, and die. That could be cute. I hadn't thought of that. That's a good one. Yeah, we gotta get the arrow shooting. So we've got where we've aimed it. I think he's gonna right click to release. And then we need to draw the arrow where it was in the animation and then have it fly off. Which, physics-wise, is not hard. We will have to rotate the arrow, which is one more piece. It will have to compute a little bit, but it shouldn't be too bad. It's similar to what we did with the paper airplane, where what we're doing is measuring the direction of travel, take the velocity and just point it in the direction of the velocity. So your heading and velocity always match. And an arrow has to pivot about its center. Yeah, there's a little bit of subtleties around it, but I don't think it'll be too bad. It was good. I was on a trip, visited my mother's grave, laid some new flowers there, also visited my brother and his family. Good. Family is important. Family takes precedence. Family needs to be visited and talked with. haven't really talked a whole lot with my brothers in recent years. You know, just when they come up for a visit to visit my parents. But we've started doing some like Zoom calls. It's been good chatting with them again. They're mostly pretty okay dudes. One of them is a nuclear engineer. One of them develops automation for medical testing facilities. And the other one's kind of an interesting character. He was an accountant, but now he's doing his apprenticeship to become an electrician. So kind of all over the place with my family. We're through the main part. Good. Build's almost done. As long as Ctrl-Q still quits and the frames per second still show up for a normal build, we'll be happy with that. Debug. So frames per second shows up just fine. And quit. Yep, so it still works. Great. Yes, my son has a very big personality. Notes. Steam build flag now suppresses FPS and keyboard quit shortcut. The problem with Ctrl-Q is it just quits. It doesn't wait for the scene to wrap up. It doesn't wait for things to tidy up. It doesn't wait for the output file, the config files to be generated. So should not be in the official release. Okay, so we're going to release an arrow, whatever that means. Steam build not have FPS and Ctrl-Ctrl-Q. There we go. All right. Okay. Now, I guess we need a picture of an arrow, which we should be able to steal pretty quickly. I think. I guess that means I need. Oh, I have GIMP. What am I doing? I have GIMP already up. Means I just need to show it. GIMP. Okay. So mostly what we need is an arrow. Aim left, aim right. I just want this out of here. arrow. Hmm. A rotation point. I want the 0-degree angle arrow. About there. We need to crop it down to size. Let's see here. I had a pencil, eyedropper. Hmm. Okay. That looks okay to me. So we're going to put the arrow somewhere. So let's see here. We're at 1024, 1023. Okay, so that's the arrow we're going to shoot in theory. Sure, good enough. Okay. All right, Robin. add the background layer so that it doesn't export. For this arrow, layer size is 39 by 15. And this is 1024. So our texture starts at 1. 1024 minus 1 is 1023 minus 15. 1023 minus 15 is 1008. 1008. Okay. Hide the GIMP. Spent the morning playing with Obsidian. That might work quite well for my mental process. Thanks for the suggestion. Yeah, I was going to ask if you'd had any time to try the two different ones out. It's not bad. I've started using it to run a D&D campaign I'm running. I don't meet that often, so I figured if it was searchable, it might be better than what I usually do. Yeah, note-taking is apparently its own art. But my problem is, like, I'll watch some YouTube videos about note-taking by somebody, like, oh, there's this tool and there's this process, but then you look at the rest of their channel, and like that's all they write about is taking notes. It's like, great, you're really good at taking notes, but like, did you accomplish anything else? Like, what actual projects you're working on? Are you just taking notes to take notes? So, I don't know. Kind of becomes its own end instead of a means to an end. All right, so we need assets, images. Robin Hood needs a UV rectangle called arrow. All we really need then is this rectangle, which is 1008, and it's 39 by 15. So we should be able to spawn on arrow. Is that it? Chalk Archer. Texture quad. We don't have a target yet. We don't have a scoreboard yet. That's fine. But we do need a texture quad m_arrows. Static constant. Num arrows. I don't know how many. 6. Maybe. I'm just going to walk over them and initialize them. Set texture. Let me set the UV. To arrow. So that's one piece of this. We need to, in render, show any arrows. Let's see here, an arrow enabled equals false to start with. In render, we render each arrow. Okay. What else do we need? We need to know which arrow Robin is shooting. Arrow index equals target scoreboard. Let's start with -1. I looked at both options. I like this one a little bit better. It has a lot of features, works well with the minimalist approach I use. Watched a couple of those videos as well. I was initially put off by the complexity, but was pleased with the base simplicity. Yeah. All right, you're gonna head out? Yeah, I'll still be here probably. You have a good stream yourself. Good luck. See you on the flip side, kangaroo. Okay, so the question is, when I release, let's see here, right click, shoot. If we're in an aim state, we shoot. Set Robin's state, probably the idle for now. We should have a to-do animate drop left right. We set the state. Arrow index equals well, let's start at 0. I will throw myself off if I don't do it that way. Arrow index. Texture quad underscore arrow. Let's see here. Equals underscore arrows at underscore arrow index. Arrow set enabled. Let's see here. Enabled equals true. And we need to put the arrow. Oh, show later. Yep, catch you later. We need to move the arrows somewhere, and we'll refine this. Move to Robin.o. We need to do a thing there. So this is going to be relative to Robin, but we're going to be up and forward the arrows, arrows. We need to do a couple of different things here. This thing now needs 9 children. Init elements. Arrow set parent. No. Add child. Arrow. Here we go. That's easy enough. move someplace, we have to calculate the angle, which is part of aim anyways, which is here. No, not that one. Not walk. Aim. Here we are. Aiming right. So we get our screen X, Y. We compute our angle. And whether we're aiming left or right, blah, blah, blah. Might as well just copy this whole thing. Okay. We get our screen position. We get that. We get that. For aiming right, we do not care about sequences here. We just care about angles and power. And we do clamp the angle. Otherwise, we're aiming left. And power. And angle. Okay. Getting there. I'm going to take a quick restroom break. Just for a minute. We'll be right back. Wow. Okay. Be right back. Okay. Now, back to it. Power. This angle is not quite right. Shooting right is fine. But if we're shooting left, we need something a little different. So 0 is pointing right. And 80 That has to do with this frame index though. So actually aim left kind of doesn't matter. Well, it kind of does because of the clamping. So 180 is pointing left, minus 40. Oh, so do we add? Mm-hmm. 180 down to 220 and up to 110. So that's what I think we need. Now, if we have an angle and we have a power, we compute our angle. We should have everything we need to shoot. Turn the arrow on, enabled, move to somewhere. Blah, blah, blah. Rotate. What is it, rotate 2? I don't remember now what it's called. Yeah, rotate 2. I'm 90% sure that has to be that already. Math. Deg 2 rad. Come back. Okay. Init elements. A couple other things we need to do. We need to set the size, so we need to get the float with height. We can get that here. Image warehouse. The key arrow into our width and height. We can scale it to our screen size. Set rectangle to 0, 0, width and height as scaled. And set center to half our width and half our height. So so the rotation point of the arrow should be in the center of the arrow. I think that's it. So the arrow won't be in the right position, but it should at least be oriented right or something. Let's make sure. Let's play around with this a bit. we know the end position of the arrow, but not the center of the arrow. Although we can probably compute that, since we know the pivot point while you're aiming. As long as we're within a pixel or two, it should be fine. All right. Reorder. Arrow. Oh, that's because we didn't embed it. So, CD tools bin dot slash embed PNGs. Come back up. We're going to go to our make file. Suppress that. Rerun our build. Ooh. So we can get this bad boy shooting. All we're aiming for right now is an arrow on the screen near the archer, rotated the right direction. Okay. Parentheses, no good. Idle. Oh, it's idle 1. Power is not used, that's correct. We're clamping that power either. So basically we're going to use the power to set the initial velocity of the arrow, then let physics take over. Draw. I don't see the arrow appearing anywhere. I don't see the arrow. Hmm. Hmm. We get our arrow. We enable it. We move it somewhere. Which right now doesn't make any sense. Well, maybe it does, but let's just try another location. Arrow. Put it in the middle of the blackboard, maybe? Maybe it's a position thing. Draw. Release. Huh. Okay. Well, let's go take a look then. Go back to our idle state. Angle and power. Power and angle. Let's see if we're just even getting in the ballpark here. No, 65 is not right. Okay, the angles always come out wrong. Maybe. Printing it right. Oh, by the way. Because these were locals shadowing it. Still. Let's just rerun this. Do a tidy debug build. Just make sure our data is all there where we expect it. Oh, I bet. Hold on. I might know what's going on. We're going to show GIMP again, because we're also going to want another asset soon in a second. Anyways, you duplicate layer. Mark's going to move this guy somewhere. Sure. I'm going to rotate 90 degrees. Then I basically want everything here to be white. That's pretty close, actually. Hue, saturation. I would really like this to not have that weird pink in there. There we go. More alpha. Okay, cool. Copy. Okay. So there's this little fella. We need to add into our images file. This will be 15 by 39. It's going to start at 67. And 1024 minus 40. 1024 minus 40 is 984. Okay, 984. Save. Export. This was our problem. We were getting alpha channel stuff. Okay. 984. Now we're being bid our image data. Just get our stuff showing up here. Okay. Okay. So what we actually want is like 5 or 6 of these chalk arrows drawn as a mark. So you know how many arrows you have left. Then when you right click, the chalk one will disappear. And the real one won't appear until you right click again. Okay, things show up. We're in good shape. Okay, draw. There's an angle. There's our arrow, so we can shoot at a steeper angle or a shallower angle, and they'll all appear in the center of the board just right. So if we shoot that way, there is an arrow pointing that way. Yep, looks good. Just the way we want, sort of. Okay. So if I go to here, this goes away. We adjusted for, oh, interesting. This sprite frame height minus hand of height by the ear. These values should be calculated relative to things. That's also true then below down in here, where we stole that from. These numbers. Sprite frame width is actually not that hard to get. We can use robin.rect.width divided by 2. Robin rectangle dot height over 2, not over 2, minus 46. This is the part I kind of don't like. It's okay. This is not an expensive operation. Okay. So what we want then, basically this, which is not quite right. This will put us close to where we want him. When we move to y, well, the top edge. So top edge says is my y-axis plus my height. Oh, no. Plus rectangle dot height minus that. Take that for a test drive. We got a mismatch put in somewhere for inexplicable reasons. So that'll put the arrow centered over basically Robin's ear. Or down below. Okay. Which means I overthought this. Shooting the arrow, blah, blah, blah. White is our top edge. Oh no, why is my feet? Rectangle height. So I think it's this. So from the bottom of the feet, move up the height and then back down some of the way to get the center of the ear. I feel like we're close here. Okay. 6. Is that the thing I'm overthinking? Because we're gonna have to move that by half the width and height of the arrow along that angle. It feels a little too low for me, so I think. Did I say plus instead of minus? I might have. I did. Yeah. Using power, that's fine. Okay, so in theory, half the width of the arrow is the difference. Yeah. Plus equals big 2 rad angle times, what did I say, 39 or so? Well, this is not correct, but even 39, I don't know, something like this. Quick restroom break. Be right back. Okay. Cosine sine, sine cosine. If our angle I think. Let's just see what we get. Otherwise, I'll have to do math. Probably isn't the worst thing in the world. Those. Oh. Okay, well, I'm a little silly here. Gotta put the parentheses in the right places. Is my audio on? It should be. Should be on. Audio test 1, 2, 3. Sounds okay to me. I think the audio is fine. This is more like 19. This will be more like 7.5. It's half. We'll come back to all that in a little bit. The y might be negative. We'll have to move that other direction. Conspicuous. The y is upside down. We'll get back on, not sure why Stuff shuts off audio feed. Interesting. Stepping out for a bit to move a chicken coop. Oh, I thought you were going to do that on Saturday. Well, good luck with your chicken coop. It's a good thing it's not a chicken sedan, right? So why? My other fear is that the individual components have to be negatives, and I'm looking at 4 different possible permutations, which I don't like to think about. Nice, that arrow appeared right where the last one was. Okay, small pop. We don't need this part. It's one of those cases where it would probably be faster if I just sat down and did the math, but we do it the slow way. Not feeling the math this morning. Okay, so we draw our arrow. There's just a couple of pixels off the end that we don't need, so 16. I'll get us real close. If that's close enough, we're going to do arrow count management. Arrow count management. What else? I'm fine with that. That looks fine to me. Is that true? Let me take off that last little couple of pixels. 14. All right. Arrow management. Okay. I'm going to say those are good enough. Arrow management. Therefore, every arrow it's actually going to start off a little differently than we've said so far. Arrow mark. We're going to get the width and the height, blah, blah, blah. We're going to set our rectangle. We're going to set our center. X and Y. We're going to need a spacing, small space, right? Oh, X, Y. Set bounds. Okay, so this one needs move that if we need to. We need this thing X, Y, Z. Equals X0. I just want a little spacing around there. Let's float. Small space equals scale 10. Back on, let's see, yep. It'll be X plus small space. So, no. Plus width plus a small space. Y1 minus total height. I don't know. Probably a function or two for these things. WH. Basically, we want to always preserve 6 arrows on the screen. Don't see them. Um, we need a function for this. I need the ability to in 3 different functions. I need to void retrieve arrow, load arrow, fire arrow. Right, retrieve arrow is like a combination of my init elements here. Retrieve arrow, load arrow. So we need this here. Assert index greater than or equal to 0. Assert index less than num arrows. Arrows left index. Into set texture, set UV, set rectangle, set center. Load arrow, arrow point to enabled equals false. Fire arrow, true. It's not when we init elements. We actually don't have to do any of this stuff here. Okay. But when we let's not do it that way. Texture quad. When we initialize, we don't want the arrows to show. We're going to add arrow and arrow enabled equals false. Set bounds. Retrieve arrow. grab this. Let's move this below here. So when we retrieve an arrow, we make sure that it's the arrow mark. Set its rectangle width height, center, except this space x is x naught plus rectangle width plus a small space y equals y1 minus WH. And up, move up. Actually, this is a plus, we'll just put parentheses around it. Oops. Y minus half our height and a small amount more. We grab the arrow, we move to, we don't have to do that. Let's put ourselves directly at x, y with height, set center, load arrow. So when we do right, no, when we start aiming, right, or draw, then we load arrow. When we load an arrow, what we're looking for is the first arrow that is available for x equals 0, x less than number of arrows if arrow is enabled and arrow point to get UV, or let's see, I thought texture quad had a thing for me there. Texture quad UV key. Equals UV key arrow marked. And break. Arrow equals that. If arrow not enabled is not true, if this was the disabled one, I'm going to turn it on, and we're going to do a bit of work here. It will look like this. Get the arrow itself. We'll get the texture, set the UV, set our rectangle, set our center. The arrow. We don't actually need the arrow index anymore. That's not a thing. Fire arrow. Right. Compute location, angle, and power. Update visuals. Blah, blah, blah. We need an arrow index, actually. All right, so get our visuals, location, angle, and power. Move to, rotate to. Okay. All right, a little bit more mate left. Don't need to warm it up just yet. Okay. All right, we got some copy paste errors, it looks like. All right. X0 is not declared. That's because that is now X. Let's see, bound X0. And let's for bound Y1. Okay, getting closer. We should definitely scope our methods correctly. Okay. Okay, now we're getting close again. Mostly we want this to not look different from what we just had. Except my arrows aren't showing up. It's sparing the wrong arrow. It's not drawing the initial arrow. Plus index times width plus small space, which really is just here, plus index plus 1 times that. The y doesn't matter. Y1 minus the arrow white plus small space. Retrieve arrow. Okay. Okay. I don't feel like that fixed anything. Fire arrow. Load arrow. And for any old arrow, which is enabled, is in that mark, we enable false. So it should stop drawing it, but it's not drawing in the first place, so maybe that doesn't matter. Fire the arrow. Right texture. Um, not saying is the expected white arrow. So where are my arrow marks? I would expect about 6 of them right about here. I want to see them disappear. Retrieve arrow. Retrieve arrow. So where are my arrows? I retrieve the arrow. I know the UV exists. I don't see any arrows. Oh. Oh, interesting. Okay, so shoot, that's fine. That's fine. I'm okay with that. Retrieve arrow. Load arrow. Fire arrow. whichever one is disabled. I feel like I'm close, but I'm not sure. Come on here. Oh. Maybe it's this rectangle dot x. Rectangle dot bottom. So that's the y at the bottom. Moving up. That was a copy paste. At that point, we knew bounds, but we need a relative position within the rectangle, I'll bet. Nope. Nope, nope, nope. Where are my arrows? Where'd they go? I don't know. Just give it some numbers here. Something to show up on the doggone chalkboard here. Hot water already. Oh, winter. And also, brain seems to be running a little bit slow today. Where are they? Where are my chalky arrows here? This is very close to what we want. My chalk thing's showing up. Okay. Go like this. I'm just gonna put it all in the middle. Wait. Oh. Let me do this. There's no X offset. I bet it's, we're adding the width. It's already off the edge when we start. I have to remember what space we're in. There are 6 arrows. Good. I need some more hot water. I'll be back in a minute. Okay. This shows up now, so all we have to do is basically this. And this. Half height plus small space. Go up more. Try that real quick. Good word. Okay, now we have 6. Perfect. I want to fade while we draw. So let's see here. Retrieve arrow, load arrow. I don't want it to pop. I want to do the following. Let's see here. Archer. We have the scheduler. We have the scheduler. Animation. Getting an animation. Set duration. Some amount of time. Set use scaled time false. Set duration. Set range 1 to 0. And I think arrow double value texture quad set alpha. Nope. It's fine. C dot alpha set alpha float to our value. Arrow point to set color C. Animation action sequence. Scheduler. An action sequence with 2 actions in it. Set play animation. After the animation is complete, immediately do the following. To the arrow. Enabled equals false. When we do the reverse of the color check, we can set the color back to where it was. There we go. Basically, we want the chalk to fade out, and then go back. When we right click. We'll see how that goes. Okay. Okay, so that's working. Other thing we want to do is draw, aim, draw right, handle mouse press. If we load an arrow, we do that. Loaded arrow equals false. We get here, then we did load an arrow. It's true. Return loaded arrow. When I run out of arrows, it's fine. It won't draw the bow. Now he doesn't do anything because we're out of arrows. Perfect. Okay. We're so close now to being where we want to be. Retrieve arrow. I kind of want the arrow to fly back to its location. We aren't even detecting that, so let's go handle mouse press vent. Okay. If we are aiming, drop to idle, fire the arrow, which we're not done with yet. That's fine. If Robin contains our screen point, then we load an arrow, maybe. If we're idling or walking, blah, blah, blah. Robin state equals idle, and Robin contains a thing, try to load the arrow. Else, if we're idling or walking, etc., this needs to happen later. Right click on Robin. I don't need cheap viewers, I need rich ones. Okay, we're gonna do it this way. Number of arrows, increase our index. Okay. Extra quad star arrow equals arrows plus index. If arrow enabled and arrow UV key, original house UV key, arrow, and so we got a chain of ands here. Arrow point to contains screen point e.x, e.y. So if the arrow's on, if it's not the chalky version, like the white chalky version, and if it contains the mouse click, and we do these things. Click arrow equals true. If we have not clicked on an arrow and done all the rest of this stuff, retrieve arrow at the index. Which is not as done as we would like. And or oh, and it's one of these states. Right. Okay. Oh, we're getting close to doing the physics. Nugatory, very nice word. Okay. So let's walk over here. Shoot. Okay, now click this arrow, and that one, and that one. Kind of. Okay. Last piece then. Not last piece, but retrieve arrow, rotate 20 degrees, radians, doesn't matter. Are you doing ballistic trajectory physics? Not yet. It'll be simple, cheap physics like what we did with the bouncy ball. We probably won't even have a drag term in it. So basically, gravity, and that's it. Everything else will be, like the horizontal axis will be preserved, no drag. Just very, very simple. So I think we can get away with it. Okay, so if we right click this one, that one, that one. Right click. Okay. So retrieving the arrows works now. Not a lot of drag in 2D. Yeah, chalk is a low friction material on a chalkboard. That's how we're going to play this. Okay, so we have two options. We want to retrieve the arrow with no animation. Most of the time. Retrieve arrow, full animate equals true. With animate, we'll do one thing. Oh, I can do that thing. That's the wrong direction of brackets. There we go. We know the width, we know the height. Okay. If animate, what we want to do is compute where the arrow goes to, location, rotation, which in our case would be 90 or minus 90. Animation anim equals fiddler get animation. Set use scaled time defaults. Set duration second. Set range. From I think rotation scale angle. From there to math degrees to radians. of 90. Apply it to arrow. A arrow. Rotate to a. You need an action sequence. We need 2 animations and then this. So we need 3 things to happen. Set start animation. And get another animation. Same amount of time. Range, arrow, rectangle.x, arrow, rectangle.y, to some other location. If we need to compute, move to. Okay. I'm going to compute the position the same way we do for retrieve arrow. Right. Move to XY. Oh, I've already computed it. We computed it here. Okay. Then our sequence set play animation. Step 1 to this new animation. From to thing. Okay. And lastly, sequence point to set immediate. After the 2 things are done, I want to set an easing curve here as well. I think we want quad in these easing method quad in. If I don't like it, we can change it. Immediate. At stage 2, which takes our arrow and basically does that. Okay. Set bounds. Retrieve arrow, do not animate. Just slap it in there. Call it good. Guess that's it. Let's try it. Time for bed to rest. You have a wonderful evening. We'll see you tomorrow. Oops. A couple of issues here. W is not captured. That's easy to capture, as are X and Y. Yeah, I figure if by the end of this week we're done with the chalk doodads, that's kind of my goal. None of the other chalk doodads are quite as complicated as this one. So if we get this one done today or tomorrow, solar system one will be fun, easy, I think. Schadenfreude, always a good word. Okay. Okay, so we can get the, let's walk over here. We get this one, boom, boom, boom. Okay, well, they're upside down. So instead of 90, we need minus 90. Minus 90. We're going to like minus 270. Force an extra spin or two. I don't know. Let's see what it does. Maybe we don't keep score. Maybe just let you shoot around. I don't know if I need a sound for the bow to shoot or not. I don't know if it's necessary. Or walking sounds. Ooh, panegyric. Good word. Okay. Oh, that's not too bad. Honestly, I've seen worse. Okay. Click, 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 click. Ah, okay. Retrieving arrows is working. All right, all the arrow states are just about there. Journal, where are we at here? Release the arrow. Nope. End arrows. Right click receives. Arrow flight physics. Probably a good time to save my work. Let's see here. We've got a couple other loose ends, right? So, finish aim animations. Draw arm. And when aiming left, erase stop. And we have to do that. We need a drop bow left right animation. That one should be very simple and very quick. And state. This is very similar to the draw state. It automatically cleans up after itself. Yeah. Looking good. We should finish those. We should drop the bow, then we'll do the physics. All right. Right click while aiming. Looses the arrow. Arrow inventory now tracked. Marks fade while drawing. Right click an arrow to retrieve it. It will fly back to the inventory. Cannot draw if no arrows in inventory. Not bad, not bad. Everything else there looks about right. Character now has arrow inventory and looses arrows from aim. Okay. Not bad, not bad. Okay. The aim animations. I guess it's back to GIMP here. Okay. So these are the aiming ones here. This sequence. Oh, no, this is the draw. Aiming. We never drew in the arm. 6, 7, 8, 9, 10, 11, 12. We got 12 of those. I guess we just draw in the arm, right? These are aim right. It's this guy. Okay. Paintbrush, opacity, grunge, and 8 pixels for our dude. And white. These don't have to be great. Just good enough. Like I said, his arm's gonna look a little goofy. Because he has to stretch so far. He's kind of Gumby for us a bit here. But you get what you paid for. I'm not paying an artist for this work, so homemade it is. I know what I would do to fix it, but I'm not going to spend the time to do it. Dude aiming left has the same problem. So I think what I want to do is delete all the aim left ones. There's only 12. And then we'll just duplicate them from the other place and flip them. I think that's my plan. left. The bow goes on the bottom. The bow's going to come underneath our do. Okay, so move here. Okay. So we're going to be doing this for a little while here. Oh, that's not draw. Shoot. I want this one. We want aim. Duplicate, aim left. Left. So we just did 10, we need 9.
Well, hold on.
Nine. 8. 7. 6. 5. 4. 3. 2. One. Okay. And then everywhere it says copy. Move. Every frame where it needs to go. 3. It doesn't look great now because they're mirrored the wrong way, so they're not pointing the same way as the bow, so the arms are all catawampus to where they will be, but we'll flip those all around in just a minute. One thing at a time. Eight. 9. 10. 11. 12. Okay. then alright, he will look equally silly in both directions now with his weird Gumby Stretch Armstrong arms. Except on the left, we need to erase parts of the bow. Eraser. His head obscures it. He's pointing that way. Trying to be somewhat consistent here. When he's walking left, his body's in front of the arrow. When he's walking right... Oh, wait, what? Bow's behind him when he walks left to right. But it's a... This order needs to change. Oops. Okay, I failed to do that. That's fine. We'll get there. $11. Eraser. And 12. Eraser. Okay. So if I'm like this, it's going to swing behind me on left to right. So right to left. So walk left. Bow needs to go on top. Bow. So this is an easy fix, hopefully. There we go. Export this to Robin. So this is just the cleanup of the aim animation and the walk animation. The draw animation is correct. The bow is behind until he pulls it all the way out from behind his head. So dropping the bow, basically, if we're here, not there, that's draw. If we want, we'll draw horizontal, it's this guy right here. 1, 2, 3, 4, 5. It's the 5th one. So aim left 5. Aim right 5 and the bow. So this will be drop. Drop right, drop left. duplicate, duplicate. New layer group. Drop, bow, right. Drop right bow. So basically, whatever angle we shoot from, we released here. Because we need to erase the bow, or the arrow from the bow, rather. Because the arrow will be taken care of elsewhere. Paintbrush, grunge. I think we had that set to 4 pixels. Maybe the darker brown color. Whoa, incorrect. Come on. What's going on here? Hey, Suki. Sorry, going into art here. Decided to start working on an RTS, real-time strategy. Very nice. Making the components of a basic engine. What are you using for your basics? Are you doing OpenGL, SEL, Rust, C, C++? It's a good project. I like it. SFML. Okay, okay. I've never used that one. So I have no advice for you at all. But that is an excellent project. I always approve of people doing interesting projects from scratch. Always. Just a between a render engine and a game engine. Yep. Yep. You will gain in complexity as your game needs it, which means you learn and grow and incrementally, which I think is super valuable and super underrated. So this one is drop right. All right, well, duplicate. Duplicate. I think this one's going to be pretty quick. Little animation. I think. Oops, not there. So we need to drop the hand and the bow. Something we need to do. Release. Hand just falls. So we need an eraser. RTS. Huh? That's pretty cool. Pretty cool. Basically, you have every component to make a game, but you have to handle most things yourself. Yeah, that's kind of where I'm at right now. Adding a scene manager. Yep. So what kind of world is your RTS set in? Is it sci-fi, fantasy? So many options. to erase everything except the shoulder. And we need to end let's see here, let's go to smaller. We need to end at idle. Where's my idle? Here's my idle. We need to end here. World War One. I want to give it a more act towards battle mechanics. Cool. So you get your World War One airplanes. You got your tanks, infantry. Got some trench warfare, barbed wire. Good stuff. There's a lot you can do with a bit of a World War One setting. So let's see here. We want to end very, very close to this one. Just copy that. See, 1, 2, 3. You can do this in 6 frames, right? Idle 1. Duplicate. Duplicate. This will be. So drop right. I think 6 frames is enough. When I'm best focused on the infantry, you want to be possible to use modern tactics like the use of blitzkrieg in the earlier stages of the war. Yep. No, trench warfare kind of changed the whole world, so. 3, 4, 5, 6. So maybe drop bow right. We'll end it here. We just flip flop everything. There we go. 1, 2. Okay. Now the hand. And eraser. Fine. This looks. Just a little bit thick through there. Okay. Oof. So the body's going to rock towards this vertical. This hand's going to drop from here to there. And this hand's going to drop straight down to about there. Because the thing with trench warfare is that you kind of need someone to use fast war tactics, and when the front halts is where the attrition usually begins. Yep, it just turns into a meat grinder. Can't advance, you can't afford to retreat. Everybody's stuck right where they are while everybody kills each other until somebody runs out of people. It is a brutal way to do war. Not the bow, not the bow. I don't want to move the bow. I want to move. Oh. Dude. This one is not bow. This one is bow. Okay, so if we put this guy in here, we can see we really aren't that far off. So I guess maybe we'll keep him leaned for 1-2 frames. And we'll just lean him forward. Let's move this guy here. Duplicate. Move 6 right back where it was. Make it opaque. This copy will be 3. So he'll be here. That worked well. Three. We'll use this body, number 2. So the body will continue to lean for half of it, and then it'll straighten up the last 2. Oh, so this one is 3 actually. This one is 4. Bow, dude, bow, dude. This guy doesn't have a bow. We'll fix that shortly. Eraser. Oh yeah, everything shows up better if we do this. Oops. Yep, pretty bad. That's some cleanup work to do here. I think that hand just needs to be fixed up in some of these aim left here. Just a bit of tidy up here. Okay. There's no point in starting an attrition war in the beginning of the war. You can already see an attrition war today. Yeah. Unfortunately, well, I guess there's arguments on both sides. The one, well, yeah. Let me pause this little operation real quick. Take a quick restroom break. I've been drinking so much water, so I'll be right back. Just a minute. then we'll discuss attrition. Okay. All right. So, attrition. Wars of attrition are brutal. They often end up with greater losses than the fast, hard, brutal short wars. So, every estimate I've ever seen about World War II says that dropping the bombs on Hiroshima and Nagasaki resulted in fewer lives lost total than if we had tried to land an invasion in Japan. The thing is that the attrition almost always favors the defender, right? Because the attacker has to extend their supply lines, while the defense always gets to resupply for easier, cheaper, less time, all the different factors, right? So if you're going to invade Russia, like Germany tried to, all they did was kept drawing back. It's like, we can retreat forever. We own more than half of a continent. And come spring or fall or winter, it's too cold for you to advance. You can't move your troops further forward, or you've completely stalled out because of the mud, right? And the Russians took huge losses, but it was literally, you simply cannot keep your troops supplied, and you can't keep advancing. Brutal attrition. Germany couldn't do it. I think the only group that ever took anything from Russia was the Mongols, who, well, that was a long time ago. Because like if you think about like how a street fight starts, or a bar fight, it's a slow escalation, right? Oh, you insult me, I insult you, little push-in match, little slapperoonie, and then before you know it, everybody's hammering away at each other, right? In war, since the stakes are so much higher, you want to, or in a self-defense situation, what you want to do is skip steps of escalation, right? Because if you escalate a little bit, and then the other person escalates a little bit, and then the other person escalates a little bit, you often will both end up well beyond your comfort levels for what you would have in a normal, civilized situation been willing to do to each other, right? But if one person escalates fast and hard beyond what the other person is willing to do on the next jump of escalation, if you just go straight to, a 6 instead of, a 1, a 2, a 3, and both of you slowly working your way up, you can often get the other person to back down much, much sooner, and therefore do less damage to both of you in the end. But being willing to step over that line faster and sooner. But yeah, both sides were incredibly motivated. That's also a factor. But a lot of trouble comes in the fact that both sides are willing to escalate to the next step and the next step. If one escalated bigger, faster, harder, enough, the other would not want to take that jump in escalation. Like I said, a single serious bombing run can often short circuit years and years and years of back and forth. It's brutal, it's hard, but it often is the more kind way to end a war. Okay, so we're dropping the bow. But yeah, that was World War II. Was the mud, the trenches. We learned how to slow everything down, and both sides were unwilling to back down. There we go. Here's what we're doing. Blah blah blah. Okay. But yeah, interesting. Now, as a computer game, attrition is often not the most exciting tactic to play. A lot of attrition is about waiting. But done properly, it can also be used to build suspense. I think it's a little harder to do. But it's not impossible. I guess their whole game is built around waiting, right? Like, what's that one where you have to wait for 400 hours? I don't remember. What was it called? Shoot, I can't remember. Where you have to wait 400 hours. The Longing, that was it. The Longing. Even something like that can be made interesting. Okay, so where were we? This guy, this guy. Okay. These first two bows are a little bit wonky. Let's go fix the bows. Paintbrush. Rotated. Okay. This one becomes bow number 3. It does not look very good. Bow 1. Oh, I'll bet it's because it wasn't that grunge paintbrush. Okay, before duplicate. comes body number 5. Move. The thing with trench warfare is that the simple issue is you needed mechanized troops to pierce through, or else you'll lose a lot of men. Yep. Well, so does the defending side. Like an old battle in World War I, both sides had around the same amount of losses. Yeah. I mean, and the Battle of the Somme was absurd. It was, yeah, it was unhealthy. Unhealthy, to put it mildly. Do I want to copy both 3 or 6? All right. Yeah, that sounds like an interesting RTS. Awful lot of modern warfare turns into, well, a lot of any warfare actually turns into a game of supply lines. If you don't have supplies, you cannot win. That's kind of the bottom line. I think Bo comes second after the dude. Okay. Eraser. One looks okay. 2. It's fine. 3. 4. 5. 6. Okay, back to grunge. 8. White. Okay. Let's go to beef up that a little bit. This bow, we want to rotate arbitrarily around Control, Shift, Alt. I don't want to rotate around this point. Why can't I rotate around this point? I could swear. Ugh. Reset. I could swear Control click or something. Let me move that center. layer, transform normal. Yeah. Okay. Rotate. Oh, no, more than that. Offset. Rotation. Wow, it really won't let me do that. Okay, all right. I need to beef up that bow just a little bit. Or brown. Okay. Probably good enough. Okay. Bow 5, bow 4. Arbitrary rotation. I don't like. I have to do this by hand. I used to be able to click something. All right, rotate. Bow 2, bow 1, bow 3. Just need a few degrees there. This is probably all the wrong ways to do things, but you know, it's the only way I know how. So okay. Paintbrush. White. 8 pixels. So hand's just going to basically drop. Oops, not the bow. Hand's basically going to drop straight down. Oops, eraser. And just like before, just I think we want them there. So For have a little bit of an elbow. This is an elbow out from the shoulder back to the fist. And this one, so out there. That's kind of a bony elbow. Okay, so we're going to call that drop bow right just about there. 2 paintbrush white. Yep. And this one. All right. Do we want to duplicate all this? Not really just yet. Let's save this, export, and then we'll just test the drop right. Drop left will just enter straight into idle, I think. Okay. I've added a simple event system for scenes. Yep. Yeah, I resisted adding an event queue or event manager to my windowing and application systems, but there are just some things that are more efficient to do that way. So I did eventually. Okay, so that's exported. So we're going to turn off GIMP. I need images. Robin drop right. 6 frames per second, so it'll take them 1/3 of a second to drop it. Size is the same as everything. Offset spacing is fine. 76, 77, 78. So we need to go from 78 plus 6 is 84, 83. Robin drop right. We embed our data. And now when we shoot, if we're shooting right, we'll drop. So that goes to Archer. Six and 7. No. I want to drop after shoot. It doesn't matter, but you know. Shoot, drop, shoot. Set Robin stick, yes. Those are their pace. Drop. We need to do drop right, drop left. convention, we're doing left then right, so 7, 8. All we do is that break. Say Robin, drop right. And if we go left, we're just going to idle 1. Draw. If it's not running, go to idle 1. Now when we shoot, shoot, click arrow, retrieve arrow, set Robin state, draw right. Okay. And break. Break out of the for loop. Okay. So there's fire arrow. Drop right. Drop left. Rebuild the image warehouse. Okay. Oh. Let's see here. There are 3 classes in Scene Manager. One is the Game Manager, the second one is the Scenes, the third ones are the Scripts. Okay, it's a hierarchy. You can go deeper when you're on the top, but when you're down, you can't go up. Yep, that's how hierarchies usually go. Scenes can access scripts, but scripts can't access scenes. Yeah, yep. Were you embedding Lua? I don't remember your scripts. I thought it was Lua. Maybe it's someone else I was talking about. Their project. Ooh. Ooh. No, it's all in C++. Okay. Okay. Yeah, I'm trying to think if there's ever a time where I want a game object to modify the scene itself much. Don't think so. The scene shouldn't do much other than contain a bunch of stuff to render and to update. That's definitely a copy paste error there. button state. Drop left. Drop right. Okay. Get the bow drop to the right. Like I said, pretty simple. This thing contains every script stuff to render. Yep. You can also put code in the scene, right? Okay. Do I remember what we're doing here? Oops, we exported. Shoot. Okay, we draw. We right click. That drop actually looked pretty good, I think. So if we go over shoot left, it just snaps to idle. But if we draw right, it's a little bit of a pop, but it's not bad. So if we aim down, yeah. So we need to drop left now. That's really it. Drop left. Easy peasy. So actually, draw and drop are basically the same. None and idle are uninteresting cases along with shoot. Walk left, walk right. That's positional updates. These are one-time animations. Aim is an ongoing mouse-based animation, and these don't do anything inside of the update loop. Cool. So let's go get our GIMP back real quick and copy paste mirror things. So that looks good enough, I think, for me. I'll use a lot of JSON for data. Yeah. Like a lot of rendering stuff will be using JSON. Sure. And as long as you don't like parse JSON on the frame, if you parse JSON like on object load into a a local storage that's nice convenient struct or something, that's not too bad. It's when you start parsing JSON every frame, it's like, okay. And then it gets a little out of hand. Draw goes to aim, drop goes to idle. Okay, so back to GIMP. GIMP. Yeah, as long as it's on load, just saying, be cognizant of when processing is happening. Good. Sounds like you're thinking through it already. Okay, so drop bow right. I was reasonably happy with that. Oh, no. Can't do that. Delete layer. We have to make the bows at least fit within the right rectangle, like this one does. Otherwise, when you try to mirror, it's going to not work very well. So, and what tricks do I have for that? We go from 265 to 255, so that's 10 pixel difference. Layer boundary size. So we go to 64. We take 10 pixels off this direction, and then when this comes down to 80, we're just trimming off the bottom. Boom. So that one's good. This one, we need to trim some amount off the bottom, which is from 491 504, 91, so that's 14 pixels off the top and off the bottom. Means 70. No, but it's close. Must have done math wrong. So 71. Okay, and then this thing, we're gonna shrink it down to the right size, and then 331 to 325 is 6 pixels offset. So when we bring this guy down to 64, 1, 2, 3, 4, 5, 6. Perfect. All right, next one. We only have, I think, these two left that are rotated, so should be fine. We can make him lower his bow a little bit slower as well. We need to trim off from 491 to 507, so 16 pixels off. The height 16 is 85. Well, it's 485. I think I'm going to take another 10 off. 75. Perfect. Then the width needs to get trimmed. Let's see here. 397, 385. That is 8 pixels. 64, 1, 2, 3, 4, 5, 6, 7, 8. No. It's more than 8. What was I thinking? 397, 85. It's 12. Math is so hard right now, apparently. 64 minus 12 pixels. Perfect fit. And bow number 5. We need to trim off 491 to 511. 11 plus 9 is 20. So we take 20 off the height. And then the width, bring to 64, and then we have to trim off the leading 463 to 450, 13. Layer 64, 13. There we go. Now we can duplicate this group. This will become left. We shall move everything over to there. And our last dude here doesn't quite fit, does he? This one will move there. Okay, now this guy's left, so now we go through the renaming fun, so we don't name collide, drop left bow. Delete the trimming stuff. Oops, not that stuff. I need that one. Oh, dang it. Nope. All right, this is silly. That undo was terrible. Left. Oh. Okay. Now we mirror. Flip. 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 Oh no. This doesn't work at all because our idle is on this side. Oh dear. I wasn't thinking, apparently. Let me see, we've got... The drop on the left side involves him turning around. So if I'm aiming this way, I have to swing all the way around and through. So I actually need more frames. For that one. Because he doesn't... Oh, I didn't want to do this. Okay. Both hands and feet need to come together and then come back apart on the other side. Okay, well. Duplicate, duplicate. Okay. Shoot. I think. Eight. So the bow's going to swing a little more, This might be horizontal at this point, and then one more, and then the idle 0 animation. So 8, 9, 10. This might be a 10 frame animation. Feet gotta go. Yeah. Or do defaults to the right. So returning from left is a longer journey. Okay, so still want to end at idle 1. That is still a goal. Eight. This will be 10. And 10. Off left. 10. 10. Okay, so come to 6. Use that as a, click on that as a guide for where to put the foot drawings. There. Okay, so his hand 8. Swinging in. Oh, not that one. Oops. Eight. Duplicate. So this will be 9. Six. Eraser. That arm is going to drop straight down from 6. And that arm goes away. Move the bow. Six bow. What? Well, what is this one then? 6. 7. Bow number 8. It's going to rotate more. Erase. Erase. Okay. So that'll rotate, that'll rotate. Let's duplicate this one. Move it over here, and this will be 9. Five, 6, 7, so 6. This dude. Needs feet, not this one. Needs 7. Needs feet, not like that. eraser, paintbrush needs to be up there. 7. We'll rotate the bow in a minute. Right here, we need to narrow the shoulders even more. So 8, not a ton, but a bit. And then both arms are swinging, both feet are just kind of a blob, I guess, right? And it's kind of this shape here. A little more narrow. But then we actually want like these legs here. Comes down some. Then back up. Okay, so we have like 3 bows to rotate. 5, 6, 7. All right, layer, arbitrary rotation. Rotate around that. Okay. Layer, transform, rotate. Out horizontal. And then this one. Layer, transform, rotate. We need to fix that hand. No, I'll do that. I want to move the bow just a little bit. Move about there. Now rotate it. So that's 10 frames. Okay, so I think that's it for OBS. Let's see, where are we at here? Oh, it'd be something to make everything by hand. It is pretty cool. Now my question is, do I store the coordinates to form a triangle or a shape? But it must be convex. And I know somebody that I can't speak politics with, because the second I bring one word, he starts getting mad. Conservatives. There are crazy people in the world, for sure. I myself probably tend more towards conservative side of things in terms of the way things are being run right now. But yeah, there are people that will stop talking to people if they disagree with them. It's like, what is wrong with you people? My goodness. So I said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10. We're gonna try that. He's liberal, I am neutral. Yeah, but if you're not on their side, you're definitely against them. That's how a lot of people run their politics, and that's just sad. No fun to tiptoe. No fun to have to tiptoe around people. This arm is incomplete. What is that? Frame 5, 6. Paintbrush 8 white grunge, yes. There we go. Okay, so I think we're done with OBS, or with not OBS, with GIMP. Go to OBS. We have to add, to do this. We have to add the drop left. I think 12 feels a little bit, or 16 feels a little fast. 83, 85. Plus 10 is 95, 94. That should about do it. Okay. Oh, the thing is, I'm more on the left than on the right. Yep. And that's fine. I just like talking programming. Like, I wish politics wasn't such a big part of life. You know? I don't like that it's become the predominant cultural thing to talk about, right? I like talking about books and movies and board games and computer games and programming and there's so many other things to talk about besides politics. And what's silly is most everybody agrees what the problems are. They just don't agree on what the solutions should be. Oh, I didn't do this. Export. I gotta export this real quick. Okay. We're in bed one more time. Oh, I'm sorry, this is last time. I only said that I would vote Conservatives or the PQ because I do not want Trudeau back again in power. Yeah. Yeah, then the NPD was linked to the Liberals, so I voted for them. Then the Green Party. PQ stands for Parti Québécois. Yeah. Well, I think in the modern Western world, most politicians have forgotten that they're there to represent and look out for the interests of their constituents. And vote their personal interests, which is sad. Like, you're a civil servant in theory, which means you should be serving people. Help see kangaroo progress. Progress is slow but good. Let's just say Trudeau might be the most hated person in Canada. You say that, but he keeps winning. It's hard to say he's the most hated if he keeps winning. Like, are there shenanigans? Is the voting there not fair? I don't know enough about Canadian politics to be clear. Like, I hear the occasional tidbit and piece, but they keep voting him back in. I think his last election was one of those cleverly, before I lose more support, get the re-vote in timing wise, so I don't have to run again for a certain amount of time. I don't remember. Because of the alliance. You know, the same thing happened in the UK. There was a coalition that formed that made some people very upset. Hey, Allied. I feel I was just refactoring code for my stream. Yeah. Hey, refactors are important. You got to do them. Gotta do them. Yeah, well, any system can be gamed. And the politicians do nothing all day but play games. Yeah, so progress-wise, we've got him. He'll release the arrow. The arrow doesn't get taken over by physics yet. We have an inventory for arrows, so you have 6 arrows or something. We're just working on the animation to lower the bow after releasing. So we're making good progress, I think. We'll do the arrow physics. That should not be too hard. Except maybe what happens when it hits the edge of the board. That part, I don't know if I have time for today, but definitely the rest of the physics aren't too bad. But I wanted to see where the arrow was released, the arrow appear, so right now we're just leaving it where we release. Everything that we all know is that the job of a politician is to lie or making false promises. Yep, that's why I'm not a big fan of voting for politicians. If there's somebody that's like, I've never been a politician before, but I'm running for this position, I'm like, you know what? Bonus points to you, because you're not in the game. Some of them do okay for a little while before the game takes them over. Some of them never do, but at least there's a chance, right? By the time most people are running for high enough offices, they've been in the game so long, it's like, I just don't like you. You're a politician. You're not a real human being anymore, I think. You've been taken over by some parasitic mind virus or something. Okay, so walk, walk, walk. Right click. Uh-oh. And shoot. Oh, that's kind of ugly. Okay, so the bow lowers, that's fine. When we drop from the left side, pop. Alright, clearly we still have some issues. Dang it. Okay, are you storing the data for the inventory as separate structs, like composition, or using inheritance? Oh no, hard-coded. Hard-coded. Are you ready? Are you ready? You can see the parabolas already. Yes. No. Here's the whole inventory. You have a number of arrows and then an array of arrows. That's it. But the arrow state is maintained within the object itself here. When you draw, it finds an arrow that's just marked on the board. Well, here, let me show you. It looks stupid right now because the animation's not right, but it's actually kind of close. So come all the way over here. You can see the arrows. So when we draw, we shoot, walk, draw, shoot, draw, shoot. Yeah, that makes me sad. Shoot. You can see the little chalk arrows over here disappearing every time I draw one. Right click. And now, if you right click an arrow, it puts it back in your inventory. And now you can shoot again. But if you don't do that, you can't draw again. So if I right click a bunch, then we try to draw again. He doesn't do anything. He just idles. So you have to put an arrow back to draw again. Can't shoot. Can't shoot. No shooting. No more back. Nice. So there you go. That's kind of where we're at. Inventory is just numbers, to be honest. Yep, that's cool. There's a visual representation of the inventory. Yeah. Yeah, it's fun. Like, I'm spending way too much time on these little things that have nothing to do with the rest of the game, but it's kind of fun. Every one of these little doodads is like a mini system that might end up in a bigger game later. Like, I've got, collision detection, resolution. I've got some small physics pieces. I've got animation sprites, just all kinds of things. And it's all hard-coded and it's all bad, but it's just one system as like a prototype to something bigger and more complex. So we're getting good. We're getting good. Okay, so we have some wonky animations. Let's go to our GIMP. See if we can figure that out. Yeah, it's building up my code arsenal. That's the point of game number 1, right? I don't start with the next, MMO World of Warcraft killer, Amazon Studios. I start with something small and simple, like Blizzard used to, right? Blizzard didn't start with Warcraft, StarCraft, World of Warcraft. They started small. It was actually like 2D platformers, their little dwarf game. And before that, right? Walk, run, sprint, right? But you get in a studio like Amazon, like, we've never made a game before. We're going to build the World of Warcraft killer. And where are they? Where is that game? Anybody remember? You learn by doing. And you start with something you can handle complexity of. Then you get more and more complexity as you add skill. Okay, Archer. Oh, no, that's not what we're doing. We're going to... If I can get on the right window. Okay. So one of the draw methods had a guy doubled up. It's draw right 2. Draw right 2 copy. Okay. So this goes away. Delete layer. That should fix the weird extra duplicate. Okay. For dropping the bow to the right, so draw, drop, left. Something wonky happened there. Oh, I wonder. Okay, so this is the start of it at 493. And the end of it should be 493. Let me just 493 plus these are 80 pixels tall, 573. Okay, so this should be at 573. That's where that weird pop-up off the ground was. Then we come down 1, 2 pixels in between. And now this will all work much better. Bring our dude down. Our Robin Hood. Then that animation will look great. Or good enough, rather. Oh no! Undo. Ah! Okay. We can't quite do that yet. We have to resize the bow so that it remains relative to the other thing. Shoot. All right, bow 7. From here, 67 to 60. We're gonna lose 7 pixels off that side. So 64, 1, 2, 3, 4, 5, 6, 7. And then we can trim the bow's height, but we need to lose 560 to 570, 10 pixels off the bottom. Now we can move our dude to his new home right there. I enjoyed New World when it first came out, but I think that was just the new MMO hype. I think I was just enjoying playing with my friends, to be honest. I just see the bad reviews covering it nowadays. I'm gonna get food. Be right back. Yep, sounds good. Yeah, I don't think it had anything new to add. Was kind of the problem there. For as much money as they spent, it didn't do much. 133, 120, 13 pixels. All right, 64, 13. We need to trim 560 to 73, 13 off the bottom. 13, so 76. Move the dude and the bow. Oh, I see. I know what I did. Okay. A couple of pixels off our dude here. 560, 570, 10. And then bring it to normal widths, and that's 199. 190, so it's 9 pixels off the edge. 2, 3, 4, 5, 6, 7, 8, 9. Move. Move. And then this layer, or this line doesn't matter anymore. While we're here, we really should. 574 should be 575. Should be plus 8, 655. If we needed to add another row. 657. 737. And 740. 39. Okay. Export. There we go. Okay, so that should fix the 2 animation issues we saw. Save. Rebed our data. There should be no need for me to change anything else. Rebuild. Cool. Aero physics coming up soon. And we've still got an hour for aero physics. Not bad. I do want to know if I can make him run into his own arrow. All in all, not too shabby. So, over the last month, while that's building, looks like I'm earning about 2 cents per hour. That's not a very good salary, not gonna lie. Kind of relying on the game selling. Alright, little dude. ennui. It's a good word. Okay, so we aim. Bow drops. That's not too bad. If we aim the other way. Oh, that's not bad. I've seen worse. Not bad. I think that's it. Okay, so we're going to update those. I'm going to save that work in case we do anything stupid. Not that we would do anything stupid, but, you know, aim animations are done. Drop the bow left and right. We'll do the arrows shortly. Animations to lower the bow are done. Minor touch-ups to other animations. Aim especially. Alright, arrows. Arrows. We're gonna get the arrows finally. Animations to drop lower bow. Done. Finalized the aim animations. Pretty good, pretty good. Okay. Arrow physics. So if we go to Sir Archer, we're going to go look at the chalk ball. Okay. We have gravity, we have damping, elasticity, mass, forces, and velocities. Now, in this case, we're going to be much, much simpler than that. We're going to steal gravity. Sure. We're just going to put it somewhere. We're going to steal mass. No, we don't need mass. All we need is velocity. Gravity and velocity. And then maybe like a Boolean for each arrow. In flight equals false. Okay. I'm going to doodad chalk archer. Float underscore gravity. I'm going to raise for these three things. Velocity X of each arrow. Velocity Y of each arrow. And then whether the arrow is in flight. Gravity is good. Now we'll just bring all the way down to unit elements. Easy peasy. Okay. Pretty close. I'm gonna get a quick restroom break in. And then we'll do the physics. Okay. Okay. Now, physics. Initialize elements. So, what we want is fire arrow. Let's do some things here. Handle mouse press. Blah, blah, blah. Move to, and do the thing. Okay. Where was the index? We found an index somewhere, right? Yes, we're inside that index. Now we have power, which is this thing. Update visuals, compute location and angle. Compute initial velocity on these. Okay, so we have a magnitude and we have a direction thanks to this angle. Angle equals rad to dag. We probably need two angles, don't we? Well, no, let's see here. We can float angle rad equals math dag to rad of our angle. Then everywhere else where we do this, we can replace it with angle in radians. 1, 2, 3. Okay. Here's the deal. We have power needed for when we shoot. Yes. If power is greater than, I have no idea. We're going to clamp it. Okay, then our initial velocity will be power times this angle. Float cos angle equals sine angle We're just going to use that right here. Power times cosine of angle. Power times sine of angle. We'll put this bad boy over to true. And up here in update, are we updating anything arrow related in here? No. Int. For int index equals 0, index less than num arrows. Texture quad. Arrows plus x. Okay. If our arrow is enabled, m underscore, oops, that's not the end. And m underscore in flight, if it's in flight, then m underscore velocity y minus equals, where's our dt? dt equals time get real delta real time minus equals gravity times delta time. Once we have that position, then arrow point to move by mvel x, mvel y. Continue update heading. Rotato. Really not rocket science here, but that's fine. Here we go. We're just going to try this out for test drive. Let's see how she goes. Should make a nice little parabola, even if the arrow is pointing the wrong way, the whole trip. Let's not compound our complexity just yet. We'll build one piece at a time. Okay. And no idea what happened to it. Oh, I know one thing that happened, or probably happened. Velocity times time. It probably flew off 1,000 pixels before the first frame was over. Oops. Okay. Yes, excellent. So close. I feel like we're close. Okay. So we draw our arrow. Whee! Okay. Gravity's going the wrong direction. Velocity Let's see, if my velocity is negative, it's going up. Gravity is positive. This a plus. And we move by that. I think that's it. Problem when your Y is inverted, screen coordinates tend to go from top of the screen to bottom of the screen in most applications that are 2D, which is what we're doing here. But that means gravity is a positive force instead of a negative force, which is how my mind usually works. So just not my usual convention. Draw, shoot. I mean, it kind of did the thing. It is not moving around that x-axis very much, is it? Okay. Velocity x. So clearly we need a force multiplier if it's going to be at all interesting. Angle equals a tan 2 of m underscore velocity y underscore velocity x arrow rotate to the angle. I mean the force multiplier. Launch scale. Oh, it's just a scale, so let's make it 100 times greater. Then when we release, power times equals our launching scale. Just try it out. Oops. Index. Okay. That means we need to clamp our power at a different point. Okay. Draw. Well, that did not do what I expected. Hold. In this case, if my angle is positive, y is positive, which does not go up. So velocity is actually inverted. Plus gravity. Compute the angle moved by take out that scaling factor. for now. Let this at a minimum force to apply. Flip the Y to get the rotation for the visual we want. For some reason, I can barely hear your stream through my headphones. Uh-oh. I can find on my phone. I can hear other Twitch streamers find on my headphones too. Interesting. Maybe if I move a little closer to the mic, does that help? Mr. Master Lich. Okay, physics. Well, the arrow at least traces the right thing. What if gravity is just too big? It didn't help. Let me put on audio check myself through Twitch in my headphones. Sounds about right to me in my headphones, but you can hear other Twitch streamers and you can hear okay on your phone. That's a little bizarre. Huh. I wonder what that means. When you... But you can hear other streamers. I wonder if your headphones... I don't know. That's bizarre. Bizarre. No worries. Okay, if you're sure. I don't see anything on my side that I need to change. So hopefully it's something on your side. Not that I don't want you to hear the stream, but I'd rather it be your fault than my fault, and I feel bad. We gotta find values for shooting an arrow that look reasonable. Oh, that's cute. It's a little slow, not gonna lie. Okay, so let's... Okay, so we just need to make the physics look a little better. Power. Power can be everything from 0 to very large. Even when we're 200, 500, 2000. I want to remap. Okay, math. Remap power from 0 to 2000. Pretty sure that's remap. Math. Remaps a value from one range to another range. From 0 to 2000 to 400 to, I guess, 2000. I don't know what the right number is. and then clamp it at those values. And then gravity, just make it a little bit more, I think. Let's see how it goes. Okay, then we have to check for arrows hitting the walls. That's a thing we will have to check. And I don't know how I want to deal with that just yet. Okay. So we're as near straight up as we can. That's not bad. I've seen worse. And we aim as far as we can. Thunk. Okay, that's satisfying enough. Plunk my dude over this side. See how far we can. Oh, we can't shoot very far this way at all. Not bad, not bad. Walk him over. We can't retrieve the arrows right now because they're all off the screen and falling forever. So we should have some checks in for that. Okay. I think those velocities feel okay. We don't shoot as hard. Oh, we can't catch up to that arrow. Okay. Nice. I'm back. Yeah. Yeah, so about New World, I think that they didn't know enough about what they were doing, that they didn't distinguish enough from everything else. They started off with a huge list of cool features and everybody was super excited. But as they got closer and closer to release, they kept chopping back that list until it was just like any other MMO. So like it didn't distinguish itself from the stack. And instead of starting with a simple core game loop that was really solid and then adding unique and innovative stuff to it, they were instead trimming back the new cool innovative stuff down to the solid core with nothing to distinguish it from anybody else. So that's kind of my take on it. Okay, so that's partly it. Now, the update. Update. Where's my update? Where's my update? Okay. If the arrow is outside the bounds and it's only the tip of the arrow we need to check. Right? To do bounds check. So I don't think we can shoot ourselves, which is too bad. That would have been funny. I mean, we can maybe if we really fiddle with the numbers a lot, but bounds check. Okay, arrows. The front end. Goes something like this. Arrow rectangle width over 2. This is an angle which is in radians. So take this times width and height times sine of the angle, or the cosine of the angle. Float front x, front y equals arrow rectangle dot x arrow rectangle dot y. Okay, now if front x is less than m underscore is less than 0. Back off and stop, right? Equals false. Let's start with this, just as a simple framework, just to get things going here. The front of the arrow x is greater than the width of that front y less than 0, front y greater than rectangle dot height. Halted equals true. If we halted velocity x of our index equals 0 and velocity y equals 0 and m underscore is in flight at this index equals false. Let's see what that does. Man, I didn't play past the first few months. I heard they were doing some scummy stuff. Yeah, that's kind of any modern MMO, unfortunately. I don't remember exactly what. I did like the combat, but yeah, I could get similar combat from other games, so Overscoping at its finest. Exactly. Their ambition exceeded their skill. Okay, so now if we shoot, thunk. Oh, that's actually not bad, you know? Aim. Thunk. Alright, let's aim straight up. Weakly. Maybe our minimum height is too much still. Thunk. Let's aim straight up. Thunk. Oh, how cute. Thunk. I think I want more control over the lower velocities. Pick up our arrows. That's not half bad, really. Okay. Two things then. Archer. Where we compute our minimum and maximum velocities here. Const load. Let's put this in with gravity. Archer. Gravity. Load time underscore max velocity and min velocity. We're going to map from 0 to max velocity, m underscore min velocity to max velocity. And then we clamp velocity because these things have to scale with screen size. So instead of 400, let's go with 100. I want to go like kind of flop the thing out there. 2000 seemed like a good upper boundary. Oh, I know this is unrelated. I just finished the single player for my Pong game. Nice. Released an exe on the GitHub. The executable sometimes registers as a virus on other people's computers. Yep, so I don't sign the code. Exactly. I was wondering if you knew anything about that. It's basically you begging Microsoft and handing them money to tell people that you're not a virus. I know posting the game on Steam should not have issues, but I want to post games to itch.io. Yeah, I don't know about what itch.io does. My current idea is to create the self-signed certificate and hope my certificate gets a good reputation. Yeah, yeah. I kind of don't like that whole signed certificate nonsense. I don't want to have to ask permission from Microsoft to run software I choose on my machine. People who fall victim to viruses and whatnot are tend to. Oh, that's good. Let me draw back further. Thunk. Okay, so if we launch it straight up. All right, let's try to run over ourselves here. So we're gonna go as close to straight up as we can. Give enough height. Nope, there's not enough time. We can't shoot ourselves. Okay. That's all looking quite good. One thing I want to change in the update function, this part. If we went X, we can go past the edge that we know we should stay within. itch.io doesn't do anything to help with the virus thing. Yeah, it's annoying. Yeah. So if we go past, we want to back up by the amount of our velocity, which would put us at the edge. That's kind of the goal here, right? If front x is less than 0, so what I have then is a triangle. Where's my scratch paper? Scratch paper. Wait. So what I'm going to have is an arrow which has penetrated the wall. And I want to know this triangle. Now I know this angle. Well, it's just the ratio, right? So if I take front x, which is how much we are past, so let's see here. We have let's see here, delta x, delta y. It's just a ratio. X, y. I do kind of want to be able to shoot my dude. Maybe we reduce gravity a little bit. Okay. Here's the point, though. I have a velocity of x, and a velocity of y. It's going to be equal to the same ratio of some amount of y I need to move, and I know the delta x is this. Therefore, times vel x velocity x. I'm going to make it life a little bit easier here. X at index. Velocity y. Same song and dance. V. We're going to do other math with this. Vx. Yes. No. Not that one. this one, not that one. Okay. Vy over Vx tells me the delta y. Vote dy. Dx. Basically, how far off do we need to back it to make it look okay? So this is dx equals negative front x. Dy is minus dx times that. Sort of the same thing. Now, how much do we go overboard? Well, we have to subtract. So dx equals front x minus rectangle dot width dy. We compute that way. That's if we hit the side walls. So let's just start with that. Our little backoff algorithm. And it may be the wrong direction. Yeah, I didn't ever have any intention of using itch.io, so I don't have any research into that at all. I'm gonna screw up here. Arrow point to move by. X is less than 0. We need to move positively. I don't know about the y. Oh, take a look. If we're outside, then we need to move back the way we came. By that much. Again, I'm not sure about this dy nonsense. Move by dx dy. Try that. Yeah, I actually find so far the Steam store isn't that bad to set up, but it's just so much fiddling. So much fiddling. I got a lot of it done now, the storefront, but iteration times are a little bit on the brutal side. Okay. So we'll aim up. Oh, that looks spot on for the, well, that doesn't tell me much, actually. So if we shoot at this wall, which we missed, very clever of us. Thunk. Okay, so it over-penetrated. So if we aim up, oh, that actually looks really good right there. Thunk. Huh. Basically everything except this edge. Over-penetrated. More of a lob. So those aren't backing out. At the very least, I would expect the DX to change a little bit. Set bounds. trying to follow the physics code, but my brain is mush. Haha. Well, I can talk you through it. It's pretty simple. In this case, it's dead simple. Let me show you what we're doing here. Let's go to fire arrow. When we fire the arrow, we get the mouse position and screen coordinates. We compute the mouse coordinate inside the chalkboard, right? This is basically what this is doing, relative to where the pivot of the arrow is, right? So when you draw, your hand is next to your ear, and when you aim up or down, your draw hand doesn't change much. So that's actually your pivot that we're rotating around. So we compute an angle, and if we're aiming right, it's one thing. If we're aiming left, it's the other. And once we have that angle, then we drop the arrow into that position right there where the arrow should be, and rotate it to that angle. And then we start the other animation, right? We compute our power based on our distance from our mouse to that point, and then we just set our velocity, right? So our velocity on the x component is just cosine of that angle. The velocity of the y component is that angle. Now, and then we say, hey, physics, take over this arrow. Then in the physics, all that happens is we subtract gravity from our y velocity. We grab a temporary value for our velocity x and y. We calculate the angle of our velocity so that we can rotate to follow our velocity. Then we just move it by our velocity times time step, right? When you scale by gravity, gravity has to be multiplied by your time step as well. Then I compute the front point of the arrow. And if we're off the edges of the boundary, we halt the arrow. We say halt, and here's how much of a correction factor we should have. Set our velocity to 0, say physics, you're not in charge of this anymore, and then move it ostensibly out away from the edge a little bit, but we're not there yet. So that's it. That's physics. It's gravity, and that's all. Good old trig. Exactly. Yeah. No, this one is dead simple. The slightly more complicated one was the ball, which is not active right now because we're doing this one, but yeah, physics is simple. It's cheap physics. So if the if statements are the terminal states. Yep, exactly. Those are x, y boundaries, y boundaries. Turn it off. So if we want to see the most screen penetration on the edge of the chalkboard, we want to turn VSync on. Because right now it's hitting the edge very accurately. Our simulation is running fast enough that there's no visual delay. If we come over here, okay. We're just gonna draw and fire. Yeah, it's not penetrating at all. That's great. Great news for us. All right, pull up. Okay, that went too far, but we're not correcting the y-axis, so that's not surprising. And yeah, we're not correcting the y-axis at all. So it looks like the backoff on the sides is correct. I need some arrows back. We shoot it as hard as we can at the side wall. Thunk. No penetration, it just sticks. Perfect. We just need to fix the vertical axis then. Cool. Have a little bit of back off there, and Bob is indeed our uncle. If it's all dead. If the simulation was too slow, it might have tunneling right. Yeah, so we're getting a little bit of a little bit of tunneling right now. We've advanced far enough on the dx dy. So if we hit the side walls, we have this correction factor that backs us off. But on the verticals, you can see we did have a little penetration into that wall because the step, this vx dt, vy dt, was bigger than the amount we needed to close that distance. So we need a little back off factor for the vertical impacts as well, which will be dy equals front y. So the front of the y arrow needs to back off by some amount. Needs to move up. Up. Then, if that's the case, let me think. If we have vx over vy equals delta x, which I don't know, delta y, yeah, so it's just like that. So it's dx equals dy times velocity x over velocity y, something like that. We're just going to back off a little bit. I never know how to handle that. So there are three methods, I guess. One is called a priori. It means before we move. So here, before we apply this movement right here, you would check ahead and say, if I move here, would that collide with something? Right? That's called a priori collision detection. Then you would scale this movement by the right amount so you bump into the thing and touch. Okay? Then you have posteriori, which is what I'm doing. I'm moving the sucker and then checking my bounds. Okay? And then we have to do a back off. If you're very clever, when you sort of do both. You check ahead, then you slice time, move ahead that much, and then do the collision rebound on the remaining time of your time step. Like, you don't use up all this DT moving into the thing. You also have some time to rebound off. But we're not rebounding off, so we ignore that. We just do it all after the fact. I don't know if that makes sense. Basically, you can check before you move or after you move. And you're using greater than 0 box bounds would always be, yeah, exactly. It's inside a box, so we should always stick. Just depends on the system. So our ball simulation, I don't know if you saw the chalk ball simulation. We can fire that up here once we get a little bit of testing on this. Thunk. Okay, so that's good. We aim straight up as hard as we can. Okay, now there's no penetration there. If we aim straight up a little bit weaker, oh, it's gonna hit the sidewall. Let's move away from the sidewall. Right about there. Goes up and thump. Oh, something happened. Something terrible happened. What happened? Oh, it does not like hitting that wall. Thunk. Oh, they're up here. They moved up here. They snapped up there. Okay, interesting. Wrong, but okay. If we are less than 0, then we need to move in the positive direction to 0. Right? Oh, this one. This one. Rectangle. Height. Minus. We copy pasted too close to the sun here. It's less than 0, so hitting the okay, I kind of have to do that for a minute for Pong. Yep, that sounds like classic Pong, except yeah, your collision detection is simple. You just test against a radius. Not hard at all. I may have these backwards. But we will take a look. Alright, so if we shoot straight up as hard as we can. Okay, so now that one's broken. And that one is also broken. Okay, so I broke them both. Despite the fact that one of them was correct before. I think I'm getting streamer brain going on here. I think it's that way. It's not width, it's height. Which could explain some of our strange behaviors. We're checking things wrongly. All right, try that again. Oh, it's just coordinate system stuff. If I had the way I think of the math is not yet mapped to the way I do the math on the computer. Like I'm still using like elementary school, middle school, high school coordinate systems, but on screen things are a little bit backwards and upside down depending on a few things. So it's just me lazy. I should do the math on paper before I do it, but sometimes it's easier to just try it. Thunk. Okay, that's just about perfect. Let's come over here and we'll shoot straight up. Thunk. Shoot at our wall. Shoot straight down as hard as we can. Yeah, it's not penetrating now. So I think we're good. I think that's it. Oh, that's so cute. So cute. Not bad. We're calling it. We're calling it good. We're calling that a victory. Oh. And if it works, it works. Yeah, exactly. Exactly. So, journal. Arrow, flight physics, done. Stick in the chalkboard edge, done. Don't really care to indicate firepower. I don't think they need a power meter. Do we want to do scoring at an actual target? Or do we just want to let them shoot at the edges of the board? After some number of arrows, do something a little different, maybe. Another idle animation. So far, Robin Hood cannot shoot himself that I can tell. We did do that. Oh, which is this one? Okay. Robin Hood shoot himself. I don't think he can. We can try just a little bit. If he can shoot himself, I might be entertained making one more animation out of that. Okay, I know what's going on here. I don't think I can get him to shoot himself. He doesn't walk very fast, and he has to lower the bow before he starts walking. He has to be in an idle state to walk. I don't know if I want to keep a score. Okay, so come over here. Aim straight up, not enough to hit the ceiling. Yeah, he's too slow. He can't shoot himself. It's just too slow. He'll never get there. Okay. Okay, so that's that. Journal. Do we want an actual target and scoring? No. I have other idle animation just to break things up. He can wave. We can do a quick wave once in a while, right? Okay, last piece. Fade in and out. I'm going to remove the target and the scoreboard. We're just going to take those out. There's no reason for it. Is there a reason for it, though? We want the target and the scoreboard. Do I want a target and a scoreboard? It might be kind of fun. Wave would be cool. All right, let's go do a wave while we think about whether to keep a target and a score or not. All right, let's go do a wave. Let's save our work. Archer shoots arrows. Arrows stick in the wall, in the border of the chalkboard. Looking good. Okay. Let's go do a wave. Let's go do a wave. Or a bow. Can you shoot yourself if you reduce the power enough? So right now, let's go ahead and just take a look. The way this is going to work is, let's move over this way. If you shoot with less power, it's going to spend less time in the air. So 70 degrees is the angle we've bound it to. And it's just not going to be in the air long enough. So if you aim just right to not, let's try this knot of wood here. You want it to basically take us, because it's 70 degrees, I think the 70 degrees and then the fact that we dropped the arrow is the problem. I just don't think you have time to get under it, like, at all. Let's see, down near the bottom of the leg. Fuck. So there's like that delay before he starts walking. So there, click, 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 go, 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 go. He's just too slow. I'd have to allow a different angle, which we, okay, all right. Let's try this then. Ready? Just because, fire the arrow. Just because we clamp on 70 here, doesn't mean we have to. We could clamp a nice cool 80 degrees. So basically past what the visual shows, but the visuals are a little bit chunky anyways. They're every 10 degrees. So if we allow another 10 degrees on that, we should probably do one of these. Make file, let me do this. I'm getting some strange behaviors during shutdown, so we're just going to do a quick tidy debug build. Okay, we can try. If the arrow would just spawn and hit the player type of deal. No, if it's low enough, it looks like nah. No, so if we make the angle just a little bit steeper, maybe then you don't have to move as far, but it still spends enough time in the air if you aim it right. I do kind of want him to shoot himself as like an, not an Easter egg, but like a, yeah, sure, an Easter egg. I'm not going to tell people you can shoot yourself, but it's an option. You know, don't play with sharp, pointy things. You kind of want it to hit him in the head. About to say an Easter egg, yeah. Once he's dead, there's really nothing you can do. So we'll have to have one more state to him, dying and dead. I'm down, I just... Angles and walking speed. So it's 10 degrees enough. So let's see here, we said Right about there. Walk, walk, walk. Come on, dude. Oh, okay, too low. So if we come up to walk, come on, dude. Walk, walk. Oh, okay. All right, that was closer. We've got to find the right height. So maybe here. Walk. Come on, dude. Walk, walk, walk. Oh, that's just about it. Oh, oh. We can shoot ourselves if we allow 80 degrees. We can do it. All right, we can shoot ourselves. So we need 2 animations. Okay, so you can do it. All right. We're gonna allow this. I'm deciding we're allowing this. Yes. Animate death, dying. Death state. No interaction allowed. Like you can't pick up arrows if he's dead. You can't shoot arrows. You can't do anything. You'll have to reset the chalk doodad. Okay. I think we should do a wave, maybe a bow. Bow might be kind of fun. Fading out. Okay. Yep. All right. He's gonna die. He's gonna die. I don't know if we're gonna fit in the dab animation. Where's my here we go. All right. So we need more animations. Which is the slow? Oh, it's 6 o'clock. Okay. He can shoot himself. So we have bow, wave, dying, and then the death state. Then fade in, fade out. That sounds like a good thing for tomorrow. It's 6 o'clock now. I think we're gonna call it there. We're gonna call it there. Journal fading out. Yeah. So minor tweaks to allow Robin Hood to self-shoot. No real resolution of death yet, but it is now possible. You have to be a little bit careful with your shooting. So this is tomorrow's task. So let's just stub it out real quick. 1203 tasks. Boom. We'll put this task here. This is where it was. That investigation is done. Animate Robin Hood dying. Death state. No interaction allowed. Other idle animations, a wave and a bow, probably fine. Fade in, out. Yeah, yeah. Oh, I'm liking this. This is good. Good day's work. Not bad. We'll finish up for finally all and done the Archer doodad tomorrow. That's the answer. We have 1, 2, 3 animations, a new state or 2, and then fading in and out. Perfect. Let's save our work. Get status. Can technically shoot self with arrow. All right, we're calling it good there. Thanks for dropping in. You have a wonderful evening. I thought the holding the bow animation was a dab originally. Yeah, it's not the clearest. That brown I picked is not the most visible, but yeah. But it's not far off the dab. We could drop, dab. I don't know. Maybe just do a fall over. Have him die. Anyway, you have a wonderful evening, and tomorrow we will animate death. So, have a good one. See you then. Bye-bye.